Hello folks, welcome to the second video in the polynomials unit. Today we're going to talk about how we simplify polynomials. Because what's going to happen is sometimes you'll be given a nice polynomial. It's one of those, it's clearly a trinomial, it's clearly degree 2, whatever the case might be, right? But sometimes you're going to be given a polynomial that's a bit messier than that. And again, from your experience with base 10 blocks, you probably know what happens when you get the same shape tile, but with opposite colors. We call those zero pairs. And the reason we call them zero pairs is because when you pair them together, they turn into zero, because this is a positive 1 tile and a negative 1 tile. And when I take 1 and I minus 1, it gives me 0. And the same thing is true if I had a positive and a negative 10 and a positive and a negative 100 in my base 10 blocks. We can pair them up and they always turn into 0. So what happens when we talk about algebra tiles? Well, exactly the same thing. So if I was looking up this expression right here, we have two x squared tiles, we have a negative x squared tile, we have two negative x tiles, and we have 4 1s. Now, this looks like it might be a 4-term polynomial, but it's not. It's actually a sneaky 3-term polynomial in disguise, because these x squareds are the same shape. It's just one of them is positive, or one group of them is positive, and one group of them is negative. So it doesn't count as two separate terms, but how does it come together as one term? Well, this is where we find our zero pairs. I have one positive x squared tile and one negative x squared tile, so they cancel each other out, and it leaves me with one x squared tile, two negative x tiles, and 4 1 tiles. So we see here that we do in fact have a trinomial. Okay, so how do I simplify these things and find these like pairs, these opposite pairs, right? Well, one strategy is to use the tiles, right? So if I see that I have 4 n squareds, right? So there's 1, 2, 3, 4 n squareds, and I have a negative 1, and I have 3 negative n's, so 1, 2, 3, and I have 5 positive n's, 1, 2, 3, 4, 5, and then finally 2 negative n squareds, 1, 2. I'm running out of space. But what we see is that we have a bunch of same shaped tiles, but opposite sizes. So what we're going to do is we're going to make those zero pairs. We see that we have a positive and a negative n squared, a positive and a negative n squared, 1, 2, 3 negative n's, and 1, 2, 3 positive n's. Right, so when I group like terms, right, when I want to actually get these things together, I'm looking for those zero pairs. So here's one of my zero pairs, right, and here's my other zero pair, right, of tiles. And what happens is every zero pair turns into zeros, right? So this one goes away and this one goes away. So what am I left with? I'm left with these two x squareds, right? I'm left with my negative 1, and I'm left with these two positive x's, right? So now that I've removed my zero pairs and I've combined any like terms together, right, we see the tiles remaining leave me with the polynomial 2x squared plus 2x minus 1. And this is where we switch them around, right? I know they were given to us in this order, but again, from the last video, we know that polynomials like to be written with the highest power of x's first, and then working our way down. So really, our two x's should come first, and then our negative 1 should come at the end, okay? So if we want to model these things by using algebra tiles, we can. We're always simply just looking to put together those like pairs, those opposite, their zero pairs, in order to cancel them out and then write out what is left. We can also do this thing algebraically or symbolically without using our algebra tiles, but it's a matter of being a little bit comfortable with the symbols. So how do I do that? Well, the first thing we want to do is we want to rearrange it, because I can do pluses or minuses in any order I want to do them in, right? So even though I have a minus 25x squared at the end here, it doesn't have to stay there. So when I'm doing this, the first thing that I want to do is I want to rearrange it. I want to say, all right, well, this thing can be rewritten as 14x squared minus 25x squared, right? I can take this minus 25x squared and I can bring it to the front, and then I can do plus 30x plus 15x, and then minus 11 plus 3, right? So I have exactly the same 1, 2, 3, 4, 5, 6 terms, right? 1, 2, 3, 4, 5, 6. The only thing I've done is I've rearranged them. Now we can look for our zero pairs, or we can simply just recognize that this is 14x squared minus 25x squared. So because they have the same variable, all I really have to do is perform the operation on the coefficients. Or in other words, it's 14 minus 25x squared. So that leaves me with 14 minus 25 is negative 11x squared. And then I have 30x's plus 15x's. So 30 plus 15 is 45x. And then I have negative 11 plus 3, so that is minus 8. And there is my simplified polynomial where I have combined like terms. All right, and finally, what happens if I'm working with a polynomial that has different variables? So when we are thinking of these like terms, they have to be the same. So my algebra tiles are assuming that they are the same variable. So an x squared algebra tile might look like this, but a y squared algebra tile, even though it's also a square, it has to be thought of as being a different size, so it is a different tile. So we cannot combine them together in the same way. So when I'm looking at an expression like this, what I would do is I would again rearrange it either using algebra tiles or using the symbols, but because I might not have a good way of representing like an XY tile, I'll just do it using the symbols. So first things first, I want to rearrange this thing to get like terms together. When I say like terms, I mean same variable, same power. So if I'm looking through this thing, I see that I have 4xy, and then I have another xy, 2xy, right? Same term, both x's and y's, power 1 on each, perfect. I see that I have a minus y squared, and I look through my polynomial and I see that I have another term that contains y squares as well, so minus 3y squared. And then I see that I have a minus 3x squared, and then finally I have a minus x, right? 1, 2, 3, 4, 5, 6 terms, 1, 2, 3, 4, 5, 6 terms. So I have them all there. They're simply just rearranged. Now, same thing as before, I want to add coefficients. So if I have 4xy and 2xy, that gives me a total of 6xy. If I have negative 1, right, there is a 1 there, even though it's not written, negative 1y squared and negative 3y squared, negative 1 and negative 3 gives me negative 4y squared. I have negative 3x squared, and I have a negative x. So even though they're both x's, right, their powers are not the same. This is a power 1, whereas this is a power 2. Not like terms, so I can't do anything with it. It's simply just minus 3x squared, and finally, minus x. All right, so that is it for this video. So again, little takeaway, combining like terms, it's a relatively simple thing to do once we get used to it. We're always just looking for matching variables with matching powers. All right, so that is it for this video, and I will see you all in the next one.